Welcome back, ladies and gentlemen. In this video, we are on to the next section in which we are now going to be focusing on how to prove that a quadrilateral is not just a quadrilateral, but that it is specifically a parallelogram. We are going to be discussing 5 methodologies for proving a quadrilateral to be a parallelogram. And we are going to be using in this video them in algebraic format. So let's dive in. First and foremost, the definition of a parallelogram tells us simply that if a quadrilateral has both pairs of sides being parallel, that makes it a parallelogram. And that's what our definition tells us. But that's not the only way that we can determine if a quadrilateral is a parallelogram. And kind of luckily so, because if that was the only way, we would put ourselves in some very sticky situations sometimes. And so we do have 5 ways, and 4 of these ways are going to sound pretty familiar to you. And so the 5 ways to prove that a quadrilateral is a parallelogram is what we just said. If you can prove that the opposite sides are parallel, that's enough. That is what our definition tells us. If you can prove that the opposite sides are congruent, that also is enough to prove that it's a parallelogram. If you can prove that the opposite angles are congruent, again, that's enough. And then I want to jump to number 5 real quick. And if you can prove the diagonals bisect each other, that's enough. The reason why I wanted to jump to number 5 is because in our last couple of videos, we've been discussing the different characteristics of parallelograms. And 1, 2, 3, and 5 are all exactly the same thing as our characteristics tell us. However, our 4th characteristic was that the consecutive angles are supplementary. Be cautious. That is the only difference between the ways to prove and the actual characteristics of the parallelograms. So we kind of take out that consecutive angles being supplementary, and instead we replace it by showing that one pair is both parallel and congruent, right? Is both parallel and congruent. So you may be wondering why we don't have the consecutive angles being supplementary as one of our converse theorems. Honestly, it's one of those things where it can be used, but it gets a little bit trickier sometimes. And so there's just other scenarios, I guess, that just usually make more sense to utilize. And one of them is, especially when we're talking about things on a coordinate plane, using this number 4 to show that a pair is both parallel and congruent, it makes our lives a little bit easier. So before this video wraps up, I want to talk about a couple of different scenarios. And I encourage you to pause the video and to see if you can determine whether each quadrilateral is a parallelogram by what is given to us. So again, try pause the video and see if there's a yes or a no under all of these yellow boxes. Well, obviously we can see here that we have the opposite sides being congruent. So that is one of our ways to prove that a quadrilateral is a parallelogram. In number 10 right here, I see that the one pair of opposite sides is parallel, but that same pair of opposite sides is also the same value of 3. So that's also going to be a parallelogram. In this case, I am shown that one pair of opposite sides is equal to 4 and are congruent to each other. But that's the only information that I've given. So that's not going to be enough information to show that they are a parallelogram. In this case here, I see that one pair of opposite sides are congruent with a value of 7. And I see that one diagonal is getting split in half. But unfortunately, that's not enough information to show that they are a parallelogram. In number 13, we see here that both pairs or both diagonals are being bisected right here at this point of intersection. So that is our diagonals converse, and that will work just fine. And then last but certainly not least, we have 105 degrees and 75 degrees for our supplementary angles. And so technically, right, that wouldn't be enough information to show where it is. However, what I do want to point out is the fact that we could do some manipulation to this problem and eventually determine that this is actually 105 degrees here and 75 degrees here. But again, it's based on what they gave us right off the bat.